Hello everyone, welcome to the live presentation of this work. The title of my work is a woven carbon fiber epoxy fracture testing. This is the work that my students and colleagues did in the mechanical engineering department at American University of the Middle East. As you know, polymer composite materials are being widely used in different industries. This is mainly due to their high strength to weight ratio and high stiffness to weight ratio in comparison with metals. This is, however, when we compare specifically polymer matrix composites, resistance against fracture, against crack propagation, which is termed as fracture toughness with metals, we see a lag. The same can be found for their toughness, which is the amount of energy absorbed in the material before fracture. We see composites lag the toughness of metals. So studying and enhancing toughness of polymer composites is of interest and is the motivation of this research. To study fracture of the composite, which consists of epoxy and different types of fiber. Here, carbon fiber, it's manufactured and cut to the test specimen. They are tested under tensile testing to measure their mechanical properties. To study fracture response of these materials, fracture testing of composite is performed. Later, in bigger picture, using different failure mechanism and fracture morphology that are observed, plus fracture mechanic failure model can be developed. It helps to find fracture properties of the composite. In order to study the mixed mode, mode 1 and mode 2 fracture properties of composite, test device has been introduced in the literature back in 1983 by Richard, and this fixture, which is named as compact tension shear specimen, different modes of loading can be applied on the specimen by changing the fixture angle. This is an example of what can be found in a lab. To fabricate composite plates using hand layup method, raw materials, here carbon fiber, mat, and resin, and different tools to spread the resin and compress the plate are required. The mixing ratio between epoxy and the hardener is 4%. The roller is used to reduce the bubbles and help to spread the resin, and cutting for the tensile testing is also shown here. The next step after fabrication was tensile testing. We performed tensile testing to calculate the stiffness and other mechanical properties of the composite plate. The stiffness is used later to determine the toughness of the material. To perform tensile testing, we use this machine, Tenius Olson tensile testing machine. The model is 50 ST, and the load cell had the capacity of 50 kilonewton. Some of the calculated mechanical properties are depicted in this table here. To study mixed mode loading, and here mixed mode 1, mode 2 loading, we used compact tension shear specimen, shear fixture, and the specimen, as I mentioned, was woven carbon fiber epoxy CTS specimen. A true thickness or intralaminar crack proceeds perpendicular to the layers, and here we can study it using this fixture. The first step was to make the model, recheck the design in simulation software. Then the fixture was made, as you can see here. The position of the pin shows what type of loading is applied to the specimen. The loading is changed from angle 0 here to angle 90 degree here. 0 applies pure mode 1 and 90 degree applies pure mode 2. In between we have mixed mode 1, mode 2 loading. Here we have studied 0 degree, which is pure mode 1, and 15 degree, which is a combination of mode 1 and mode 2 loading on the woven carbon fiber epoxy. Here I have shown a shortened pure mode 1 loading. The displacement rate is 5 millimeter per minute. The crack starts at the tip of the notch and it proceeds. Later you will see in big picture at the angle of 0, so the angle of crack propagation is 0. Here we deal with intralaminar or through thickness fracture. You know, the interlaminar and intralaminar fracture, they have common failure mechanisms such as matrix fracture, fiber fracture, but the values of toughness are expected to be different here. And here you can see that it was the crack propagated all the way through in 0 degree angle. These two photos show the CTS specimen before and after applying the fracture testing, when the angle is 15 degree and mixed mode 1, mode 2 loading is applied on this specimen. The crack growth angle here was measured to be 7 degree almost. Here in the right hand side you see the force displacement for this fracture testing when the angle is 0 degree pure mode 1 and 15 degree. The force is measured from the load cell and displacement from the crosshead. To calculate the value of fracture toughness, mode 1 and mode 2, and effective fracture toughness can be calculated using these relation. The calculated value of a stress intensity factor of fracture toughness is shown here, pure mode 1, mode 1 and mode 2 components, and here is the effective value of a stress intensity factor for 0 degree and 15 degree loading angle. The maximum force, the force at which the crack opens, are compared here in this picture. So there's a little bit drop in 15 degree compared to a 0 degree mode of loading. The values of mode 1 component, mode 2 component, and the effective value of fracture toughness for 0 degree and 15 degree are also depicted in these two graphs. Here the value of mode 2 component for 0 degree mode of loading angle, it's 0, and in 15 degree loading angle, the mode 2 component is a bit is significantly smaller than the mode 1 component, as you can see here. The crack growth angle or crack propagation angle is calculated and shown here for 0 degree on the right, and for the 15 degree loading angle on the left side. For 0 degree it's 0, same as you can see, and for 15 degree the angle is almost equal to 7 degree. The growth direction or the crack propagation direction can be determined theoretically using this relation proposed by Richard. So in summary, we studied the mixed mode fracture behavior of woven carbon fiber epoxy. Here the fracture testing was performed using compact tension shear specimen that was already modeled and simulated. The value of maximum force that caused the crack opening was measured, and using those values, mode 1 and mode 2 components, fracture toughness and effective fracture toughness were calculated.